In this video, I will be discussing about cyclones. Even if you don't know anything about cyclones, you might have heard of them, especially from news channels.
विपल जो है तूफान जो आ रहा है, विपल जो है तूफान जो 150 किलोमीटर की रफ्तार से इस वक्त तक होता है, जो हवाएं चल रही हैं कि खड़ा होना बोलना मुश्किल हो रहा है। और जो ये विपल जो है तूफान है, इसीलिए कहा जा रहा है लोगों से कि पोर्ट से दूर रहिए। हवाएं जो है वो यहाँ पर खुद को कैसे अब इंसान संभालेगा, ये सवाल है। सावधान रहिए, क्योंकि अगर आप सावधान नहीं हुए तो फिर कुछ ऐसे ही हालात हो सकते हैं। यहाँ पर जो पेड़ है वो उखड़ रहे हैं, यहाँ जो चीजें हैं वो अव्यवस्थित है, लेकिन इसके लिए तैयारियां कैसी?
Leaving it there, let us discuss the importance of cyclones. So, cyclones are catastrophic events that shape our lives, and you can understand this from the example of Cyclone Bhola of 1970 that caused widespread devastation in East Pakistan, which is now Bangladesh. It resulted in over 3 lakh deaths, making it one of the deadliest tropical cyclones in history. The disaster highlighted regions' vulnerability and lack of preparedness, contributing to political unrest and ultimately catalyzing in the Bangladeshi War of Independence in 1971. So, cyclone can even lead to development of a new country. And obviously, such a catastrophic event would have an effect on social, cultural, and political life of people. And from exam point of view, you you can see that this question was asked in GS1 of UPSC means in 2022. Now that we know the importance of cyclones, let us understand what is a cyclone. So first let us understand what can we infer from the term cyclone. The term cyclone is derived from the Greek word cyclos, which means coiling of the snake. The name was given by Henry Paddington because of tropical storms of Arabian Sea and Bay of Bengal used to appear like coiled serpents. These are rapid circulations of the air in the inward direction around the low pressure area. And we define cyclones as centers of low pressure surrounded by closed isobars having increasing pressure outward and closed air circulation from outside towards the central low pressure in such a way that air blows inwards in the anti-clockwise in the northern hemisphere and clockwise in the southern hemisphere. In contrast to this, anticyclones are localized high pressure systems which with descending currents spiraling clockwise in northern hemisphere and anti-clockwise in southern hemisphere. Now let us look at the classification of cyclones. So cyclones can basically be divided into two types. First is tropical cyclones and second is temperate cyclones. Temperate cyclones are also called extratropical cyclones or wave cyclones. As you can tell from the name, tropical cyclones would occur in tropical region and temperate cyclones would occur in temperate region. Let us look at the difference between these two in detail. So, tropical cyclones typically form over large bodies of relatively warm water, and temperate cyclones are formed due to interaction of warm and cold air masses. Tropical cyclones are confined to 10 to 30 degrees north south of the equator, and temperate cyclones are confined to 35 to 65 degrees north south of the equator, more pronounced in the northern hemisphere due to greater temperature contrast over the large expanse of landmass. So, this is the main difference between tropical cyclone and temperate cyclone. Now, let us look at the formation of cyclones. There are mainly three conditions that lead to development of cyclone. Uh, First is large water body and temperature around 27 degrees Celsius. This is sea surface temperature and Coriolis force. Other conditions are also there, like there should be high humidity, rapid cooling with height, ITCZ, etc., which makes it a very complex phenomena to understand. But for our better understanding, uh, these three are the most important conditions for development of cyclones. Now that we have all the ingredients for the development of cyclone, let's make a cyclone. But first, we have to make it spin. So we should understand, why does a cyclone spin? Why does a cyclone spin? Before understanding this, let us look at the forces involved. So, there are mainly two forces. First is Coriolis force. It is a apparent force because of rotation of Earth, and mainly because of difference in rotational speed of Earth at different points. For example, Himachal would rotate at different speed, and Kanyakumari would rotate at different speed. So, say uh, you want to throw a stone from Kanyakumari to Himachal and you throw it like this, you would expect that the stone would end up somewhere in Himachal, but you would find that stone would end up somewhere in West Bengal. So this is how Coriolis force works. So in northern hemisphere, let's say this is northern hemisphere and this is southern hemisphere. In northern hemisphere, uh, due to Coriolis force, objects get deflected towards the right, and in southern hemisphere, objects get deflected towards left. So this is how Coriolis force works. Now let us look at the second force, which is PGF, pressure gradient force. It is because of difference in pressures at two different points. Uh, that is why air moves from high pressure towards low pressure. Mainly because, let's say this is a thermally induced low pressure area, and you would see that air or wind here would move upward. There would be convention current, and it would move in up in vertical direction, and it would create a void at the surface, and to fill that void, air from high pressure would come here. This is what creates pressure gradient force. So you can imagine it like, you are working at office and you get pressurized for to do a lot of work. Now what would you want to do? You would want to go to some peaceful place like Himachal or Uttarakhand, where you don't have to deal with that pressure. And in the similar way, wind also moves from this high pressure to low pressure area. Uh, Now there are some other forces also involved, like gravitation and friction, but we don't need them right now. It won't affect the result. So we will just take these two forces, and on the basis of these two forces, let us analyze, or let us get the direction of air around the cyclone. So we have already discussed that air or wind moves from high pressure towards low pressure. Uh, to understand this, let us differentiate this and just imagine one particle here. Let's say this is particle X, and it wants to go from high pressure to low pressure area. Now let us see how it would move towards low pressure area. Now let's say this is northern hemisphere. So object would experience Coriolis force and get deflected towards its right. And this is low pressure area. This is high pressure area, and particle is moving from here to here. And suppose it reaches at this point. Now it wants to go here, and Coriolis force is acting in perpendicular direction to the PGF. This is PGF and this is Coriolis force, and the resultant force would be somewhere in this direction. So particle wanted to go from here to here, but it would end up reaching at this point. Now when it reaches at this point, it again wants to go to the low pressure area. So it would experience PGF towards this side, but it would again get deflected due to Coriolis force, and the resultant uh, position would be this. So particle wanted to again go from this point to this point, but end up reaching here. Now again here, particle wants to go from this to this because of PGF, but gets deflected towards the right and in perpendicular direction towards this, and end up reaching here. So you can see here that particle is following this kind of movement, which is basically revolving around the low pressure area. Let me draw here again. So this is northern hemisphere, and this is particle X, and this is low pressure area. Now this particle wants to go to this low pressure area, but would end up revolving around this low pressure area in a cyclic motion. Now let us take we just imagine one particle. Now let us apply our gained knowledge to on a larger scale. Imagine there are billions of particles here, 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 here. Imagine there are millions and billions of particles here, and you would find that the movement of air or air particles would be in circular direction. They would end up revolving around that low pressure area, and that's how a cyclone ends up spinning. Now that we know how cyclone spins, let us look at the complete picture. So we know that sun shines on the earth in this way and would heat up the earth, which would warm up the oceans, and it would create a low pressure area. We have already discussed that winds move from high pressure to low pressure area. We have seen that low pressure area is developed and warm air starts moving up in vertical direction. As water vapor rises, it cools and condenses into liquid droplets, and this releases heat into the atmosphere, making air lighter. The warm air continues to rise till troposphere, which is around 16 kilometer above Earth's surface at equator and around 10 kilometer above Earth's surface at poles. And when warm air rises till troposphere, it dissipates in other directions, forming a divergent wind pattern at the top. Here in the diagram, you can see that red arrows show that warm air is rising, and blue arrows show that warm air, when cooled, starts subsiding. The central part is the eye, and this grey and reddish portion around the eye is eyeball. Eye is around 1 to 2 kilometer in area, and it can experience warm and erratic weather. Now, when our cyclone is ready, we can make it move. So, cyclones usually move under the influence of trade winds. So, our tropical cyclone would move under the influence of easterlies, which are also known as trade winds, and make landfall on the eastern coast of continents. And as cyclone makes landfall on the continent, it would soon die off because of lack of moisture. Hence, tropical cyclones form and develop over the oceans and seas, and they die off as they hit the land as moisture supply gets cut off. And there are exceptions when cyclone enters landmass along the rivers, like super cyclone of 1998, which hit Odisha and didn't die off after hitting the land. Now, let us see what they are called in different parts of the world. So, around South China Sea region, they are called typhoons. Around Australia and New Zealand, they are called willy willies. In Indian Ocean region, they are called cyclones. And around North Atlantic and Caribbean region, they are called hurricanes. And there is an interesting uh, observation here that around South America you would find very less or no cyclones. It is because of cold currents like Peruvian current and Benguela current, which are cold currents and they don't let the ocean surface get warm enough for cyclones. Now, this question was asked in UPSC prelims 2015. You have to find answer for this. This is your homework.